Hello, everybody. My name is Dana, and I'm happy to have you here for this first event of us presenting some of the experiences and problems we had with data annotation. Do you have my slides? Okay.
Yes, we do.
Okay, perfect. So I will have a discussion about what we did in dLabel.org, what are the problems, and then later on Steve will join us and present the problems and experience he had in real world about dataset labeling. So what are we interested in? We really want to know what are the end users' experience and what they really want to do, what are the expectations, the problems they are facing, and then also looking for some research community opportunities in terms of collaboration, even with some students, master or PhD students, or like some researchers, if we can provide some sort of data or support or sponsorship for some of the students. And then at the end, we want to work with the annotation companies. I know that a few annotation companies are keen to join this event. There was a different time zone for some of them, but one of them was, I think a couple of them, three of them were joining us. Two of them were only annotation companies, meaning that they were annotating as a service, and one was providing as a tool, a very famous tool. We want to make ultimately an annotation tool where annotation companies can use it, but at the same time, I don't think there is any limitations if we collaborate or work or actually express our problems with some of the competitors or other annotation tools as well. We would be happy to do that. So problem we're going to solve is all about data annotation. So from 10 years ago, where 90% it was about algorithm and stuff like that, and then 10% about data management. Now we are at the point that up to 90% or even more is about data management, data annotation, and where 10% is about different algorithm or architect of the network that we're going to use and utilize those networks and those data. So problem is data management and data annotation, and the need for data annotation is increasing. In between now and 2025, there is 45% growth rate on the need for this data annotation. So who are we? We are a small startup based in Canberra, providing very affordable data annotation service. And also we have this dLabel.org that we try to use state-of-the-art algorithm for data annotation, automation in data annotation, and also project management, data annotation, project management, and user performance. So what are the building blocks or building components of each annotation software? Here I simplified it in four different items. First, what is we call items in dLabel.org, but others call it labels or classes, all the same. That's the basic component of the annotation. Here on the right side, you see that we have annotated two guys on scooters as one item. Then we have groups. Groups is a collection of items, or here a group of items. So if on the right side, instead of annotating the whole scooter and the guy who is riding it as one item, we could instead annotate the guy and then annotate the scooter and then say the guy who is riding the scooter is a group of riding. So that would be a definition of groups. And then we have tracks. Tracks is an item over time. So here is only a single image, but if you have a video and then the item goes from frame 9 to frame 20, then you can specify this item is the same, it's the very same item in track in frame number 1, 2, and until frame 30, for example. And that is called tracks. So tracks helps with the tracking in crowded areas, if you, for example, want to track people, that would be really helpful. So we really want to know that's the same person that is there, that's not another person. And then after that, we have actions. In dLabel.org, that's a to-do. We haven't done it yet, but we are very close to do that. So action, we define it a group over time. So for example, let's say an action called fighting. A group of people have a fight, or animals, let's say. Some items at the beginning, there is no one at the end, everyone leave the scene. So action is a group over time that can lose members also. So a group could be like 5 people at the beginning, and then 4, and then it can increase or decrease. But over time, you have a lot of different interactions that you need to define for actions. And tracks is a step for us that facilitate these actions, and actions is very now easy for us to do. We have already the tracks, and then we just need to apply it for groups. Defining items and groups and tracks are actually easy. So in our website, you can, or any website, you can easily see these different sections. We have really clarified these items, groups, and tracks. We just need to add actions on the bottom. So any of these you can define, and you can create a new one and then annotate those. The difference is between the tools is some of the tools, they start with the shapes. So even for the items, they start with the shape and then they say that's an item. But we start with the definition of item, and then the user know from the beginning that he or she wants to annotate an item. So he doesn't think afterwards that this rectangle, what class is that? That's the difference. Okay. What are the features that we are really thinking over time that there is a good need for it? One of them is annotating multi-objects over time, and this action detection. So a longer sequence, for example, shoplifting, if you want to address it, shoplifting includes a good action that includes a collection of mini actions. So a person who wants to do shoplifting, first he should grab some item from an aisle or somewhere, if we are talking about a supermarket. We actually discussed this with the supermarket about 2 years ago. So then a person who grab it and then he needs to hide it and then exit from the supermarket. That's really a long sequence. It could be like a couple of minutes or even 30 seconds. It's still a long sequence. It could be broken down to a smaller set of actions. For example, action of shoplifting could include an action of person grabbing an item and then hiding it. And even grabbing an item could have other actions like extending your hand and then grab an item and then hold it and then pull it back. It's a little bit subjective, but what is really interesting is like you can define a set of actions such that these smaller actions cannot be divided any further. And the last one, we call it atomic action. You can call it anything you like, but that's something that comes really handy when developing action detections. And then another trend is annotating from multiple sources. So most of the tools, even like most advanced tools that are available, so you can download and use, or our tools the same. They let users annotate from one single source of camera. Whereas right now, the need for annotating multiple sources is really interesting. For example, one company I call here is Tesla. So Tesla used to, for example, annotate images for each cameras, and then, for example, probably for 2 cameras. But right now, they have 8 cameras, and they annotate for all the 8 cameras simultaneously at the same time. So for example, for action detection, let's say some pedestrian crossing the street or anything they want to see, most probably half of the cameras even don't have any field of view of that object. But still, they want to put all the cameras at the same time and see, okay, this is the scene, and this is what we call a pedestrian crossing the street, or a corner that they need to turn, or anything that they want to do. So in this case, they want to annotate using multiple sources because it reduces the complexities on the side of the programmers. If you have multiple cameras, then each of these cameras, sets of cameras, they have an interpretation or a network that helps you detect some of the objects, but then at the end, you need to merge or fuse those interpretation from different cameras to decide overall what's happening. Whereas in this scenario, you don't need to do that. So you merge 2 layers of neural network to 1 if you just reduce this complexity from 2 to 1, but then at the same time, the resources, you need to have all the resources that you can, even the driver's action probably. I'm not sure about their specific cars annotation, but this is really something they do, and they have addressed it even in last 2 quarters in their earnings calls that this has changed all their autonomous driving capabilities in a good way. And this also requires powerful GPUs and central GPUs further than before. When it comes to automation and annotation, we are thinking about different things that could help users to annotate less. Here is a list of them. We have active learning, and we trained for splines. We have tried it in dLabel.org. That was good. For bounding box, we have tried that as well. So what happens here is basically a data annotator start annotating, and over time, you build a model, and then data annotator keeps giving feedback, and you update the model accordingly. And then over time, you hope that the human intervention is less and less, and automation is higher and higher. Another automation is a simple fact that there are lots of object detectors. Detector is one of them, but there is a lot of them. YOLO and another one. You want to let your tool to embed those existing algorithms. So if the user have similar objects, they really don't put time to annotate everything from the scratch. So even for those objects that are there, they are still annotating because those detectors are not perfect. For example, if you use the car detector in Detector 2, and then you want to see how it works, it's not perfect probably for the angle of your camera or for that specific location of your case, light conditions or whatever. So you use that detector to annotate, and then you fix those mistakes. That would be less cost. That's the hope, but sometimes it's even more cost because you need to edit everything. So utilizing existing object detector frameworks is really cool. That tools do that. CVAT is doing that. CVAT is sponsored by Intel. They are doing that. We let users also do some of this detection too, but I don't think we have it in our website yet. And then other things, for segmentation, for example, you want to let user utilize some edge-based automation. Slick, we have implemented that in our website. So if you really want to do segmentation, you can run it. This is not ours, it's fine, but you can run it and you see if it helps you. And if it helps you, you can use control or some simple options to facilitate those existing algorithms. Similar things for segment-based automation, point-based automation. I have some more depth with these things in next slides. So here I want to show you a little bit of a demo that we can do. Okay. So here we have a data set of 50. That's what something we have it like we have an overall view of the project, what's going on. So for projects, they have different status. For frames that are annotated, they have been in internal QA and so on. Here we just want to open the project. Those things that I said about items and groups, they're all here. So let's say I want to annotate a hand. I just need to create an object, call it hand. I don't know, we can create an icon for it. Maybe we can change the color, and then this is the option that we are looking for. So we want to track it in multiple frames. And then we can also use this one to switch it to select mode. We create it. So here I can create a hand like this, and then create hand and hand and hand, but I want to use it as a tracking thing, so I don't need this one, I delete this. Instead, I go to tracks because we just created that. So I create a hand here. I try to do my best, but let's say this is a hand. So these are like a lot of frames, and then we go to the end. Eventually, the hand comes down here. So we want to add a hand here. Okay. So here in our track, we created a hand at frame 48. We can just click on that and then, okay, sorry for that. I haven't created probably. Yeah, I did. Okay, I didn't create it here. Okay, there is a bug. I need to restart. So I can create a hand here. And then I can go to this one and create a hand here. I don't need this one. Okay, this one is fine. Okay, so I have a hand here. So I just interpolate it. So once I interpolate it, so I have hands in every frame. So I have hands here, 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 all the way, right? But maybe it doesn't look good here, right? So you see that the hand is way off because this is a simple interpolation. Of course, you can utilize the existing tracking algorithm as well, but even with them, you will be off. So we tried that, but here is simple. Like the tool should let you, let the user simply edit it in the middle. So here I am at the frame, I don't know, 25. I edited that, so I interpolate back and I interpolate forward. So I go back again and I see, okay, seems that the hand here is fine. Frame 8, 7, so on. We come closer to the end. So 25 are already fine with just 2 annotation. Going forward, we check it now. Okay, hand is off here again, way off. So here we just do one more annotation. We just click this hand because we are not happy with it. We can use like binary search. We go in the middle of these 2 frames and then try to edit it in the middle. And then now interpolate back and forward to the previous points. So we were here. At the beginning, we were here on the top. So it is okay all the way here, and then here is fine. Here is fine too. Seems everything is fine. So what happened was simply, if you go back to the project, we can see we did annotate 5. One of them was a mistake I created, so that we can ignore it. But with 5 annotation, we already annotate the hand for the whole frames. So if I go back to this, what we want to do here is actually utilizing the deep learning and feedback of the users. So we really want to, we actually worked on this. We use few shots, we use like few active learning. Not much success there so far. It was a little bit okay for bounding box. Right now that you saw, it was okay. But for example, the splines, for segments, we were not having that much of success that we had, for example, with the bounding box. So here I show you detector and 2 outputs. Why I show you here the detector tool? Okay, this perfectly works for the samples they put, but for a different environment, if you look at it, still they need addition and edit. So what we try to do in the tool, similar to CVAT, is to let them come here and then like users load these ones. If they're happy with them, they continue. If they're not happy with them, they will stop. This is another way of interacting, doing for segmentation. We did similar to this one in dLabel. We haven't released it yet. We did it a while ago. It was not that perfect. So this is basically, you can call it color-based semantic segmentation, superpixel, different names, different algorithm. But this particular one, I put the link here as well, where you can find it. This, by single click, you can include or exclude a segment for an object or a segment. So if you, for example, click once, the segment that is automatically selected will be added to the existing segment. Or if it's already added, you will be removing it. And also the parameters here, okay, with one click, as you expect, you would like to say how big is the segment that I want to select. At the beginning, you want bigger or larger segments, but when you tune the project, you want to have pixel level performance. You really need to reduce the size of the segments so you can have a better match. So I talked about a little bit of automation about annotation. I would like to think that Steve has a lot of things to say about this automation, but I continue a little bit with the tool. Simple stuff that you may not see obvious also contributes a lot. For example, multiple users at the same time who are annotating. So interactions between the servers and the clients, for example, for our job, if I go back to this and then open it. So this one, I can assign this frame to someone to work with, or I can assign this, because we have users here, you can say, okay, these users can annotate maybe can have access to from frame 1 to 50, another one from 50 to 100. So you can divide the project here. But the problem is, like, if you have 30, 40, 200 people annotating in your projects, even at dLabel, like recently we have a simple project, like 20 people are working on one annotation. It's very hard to just keep track of what users are capable of. So the person who has been assigned 50 frames, finish it, and then ask you, okay, I want frames, and the other one hasn't finished it yet. So you really want to bring flexibility. One way is like to give access to anything. So everyone can have access to everything. In that case, you need to make sure if, for example, Donna has opened this one with another one, then you see this on the top. That shows, okay, now I can edit it, but I cannot save it because this is afraid that the other person is working at the same time here. So I'm not sure if I can grab it, okay. If I click on that, it says you don't have permission because what? This one is using it. So this one has the permission, it can include and it can resize it. So if I go back to the slide, simple multi-users capability is actually really needed. Most of the tools that don't have it. And then live annotation, another one. We were thinking about the live annotation, meaning that if you are at the same frame, you can see what exactly the user's doing at the same frame. The problem with that is a lot of interactions that is needed. And most of it is just not perfect because, for example, if you draw a spline, the spline there needs a lot of edits. So you see all those little edits at the beginning and a lot of communication with the server. But eventually we will do that. Another one is automatic QA. So for automatic QA, you can develop deep learning methods where they can you look at the data anomaly, look at the model, see what's odd, who is not really in line with the others. You can use some analytics as well. We used that for data anomaly for splines, I think, but it was not much successful. But automatic QA definitely will, one part is data anomaly, but other parts would be eventually you can build the detectors, and then you can look at the result and see how good are the annotations. So from the annotations, you can build a detector. From the detector, you can go back and see what annotations are really a little bit strange, and then find them as well. We're talking about like millions of annotations here. It's not easy to do all manually. Another fun fact is simple graphs and visual information that can give all the information at once. Without them, a tool will not be successful, because literally you need to chase. You do a lot of queries, SQL query here and there. You need to ask who has done what. Tell me what you have done last night. So this is a simple state of a project where you can click on each of them and can give you these bars. It can give you overall, for example, from one frame 100 to 200, everything is a state of start. We haven't started, but the frame 1 to 100, there are already other colors in the middle. You can click on that and see the details. This is for the state of the project, but you can also check the progress. We can create similar graphs to see, okay, how much we annotated yesterday or the day before, or how much is the progress, so you can have a proper estimation of when to deliver the project. Another interesting topic here, I think I have a few more minutes, then we go to Steve, is flags. Flags are interesting. For example, this one here, the object here, I'm not satisfied with it, or at the frame level. So I can just say something here and then make it red. And I actually can draw. I can draw, for example, you forget this part. So this is very important and very simple. So you save this, and next time you click on it, you see it. So these simple facts, it could be emailed to the person, and then the annotators or QA, they all be happy if they see this. They call this issue tracks, different things. But visual graphical information, I really like it about dLabel. So we can go about the history of annotations. That's also important. You see on the left side, the black is the first version, the red is the second version. You really need those things as well. So these are simple facts that helps annotation a lot easier. And then we did a little bit of experiment with different tools, dLabel, CVAT, Labelbox, Super Annotate, Super Wisely, and a couple of others. I put the table here. We will share these slides later on after this event, so you can go back always to them and see if you have some points to say. But here, for example, we have the speed. They could do 10 annotation per minute. In this particular case, 10 image per minute for dLabel, but 11 for Labelbox. I don't know why they were lazy on dLabel. I was expecting this one to be better, but anyway, this is an honest feedback. What I'm saying, that what are the features each of them has and others that are missing. And these are the resources. And now I hope that we can find Steve, and Steve can continue from here.
Can we find Steve? Yes.
Yep, I'm here.
Good afternoon, Steve.
Hi, how are you?
Very well. How's it going? Thanks for being with us today. I'm sure everyone excited to hear about your presentation. The stage is yours.
Okay, thank you. I'll just share my screen, and so you can hear me okay?
Yeah.
Okay, great.
And we can see your
excellent.
screen.
All right, so thank you, Sanaz, and to Dana for inviting me. So I'm going to talk about the IKEA, let me start my video as well so you can actually see me. Okay, great. So I'm going to be talking about the IKEA assembly data set that we recently collected and annotated, and some other experiences that I've had in particular with data set labeling. So just getting onto the right screen. So as Dana sort of correctly pointed out at the beginning of his presentation, that machine learning these days is primarily about data, and not just data annotation, but data management and you know, everything to do with data. So here's a quote from Andrew Ng, who I'm sure you all know, very famous machine learning professor and practitioner. And so he's recently been quoted as saying, when a system isn't performing well, many teams instinctively try to improve the code. But for many practical applications, it's more effective instead to focus on improving the data. And that's sort of really the crux of machine learning and deep learning. To get your applications working well, you really need to focus much more on the data, not just the volume of data, but the quality of data, as opposed to the algorithms and the code. So my sort of move into machine learning and data set annotation began many years ago when I was doing my PhD, so back in 2008. And back then we were looking at very small data sets. So this is well before the deep learning era. And I was involved with a project where we were doing semantic segmentation. So here the task is to take an image and to label every single image in the pixel, every single pixel in the image with a semantic class label. So it can be road or car or tree or building and so on. And then the other thing we wanted to do was instance-based segmentation. So with for every pixel, you say what instance it belongs to. So you can see in the second row there are multiple people in the scene. The second column has colored those people differently. So this was a data set that, as I said, we collected in 2008. It was a very small data set by today's standards. So there were around about 800 images in that data set. But we didn't have the tooling to be able to go out and crowdsource annotations for this data set. So Mechanical Turk was just starting up. And so at the time, we developed this Mechanical Turk application, which was quite rudimentary. It would show a Mechanical Turk worker a single image, and they would get to paint over that image the semantic class labels. So they could pick a region label, could be sky, tree, road, grass, water, and then they could draw over that region, and the pixels get colored. So so note also that we were charging 10 cents per hit. So every annotation that we got, whether it was a semantic annotation or instance segmentation, we would pay the worker 10 cents for this task, and it would typically take a couple of minutes for them to complete this task. So we sort of put this out there, and we got various quality labels back. I'll just show you some examples that we got back. So a lot of the examples we got back were quite good, but occasionally we get examples like this. So here's the original image that was shown to the worker, and then on the right, I'm showing what the instance segmentation and the semantic segmentation look like. So you can see here the instance segmentation is completely wrong. It's not what we asked for, and so we'd have to go back and rework this image. Similarly for this image over here, so these are two people walking down the street. We got very good semantic segmentation, so the pixels were colored right semantically. But for the instance segmentation, this particular worker chose to give us a very detailed line drawing of the image. Must have taken hours for them to complete that line drawing. Normally we would have rejected a task if it was incorrectly performed, but we felt sorry for this worker, and we ended up paying the worker the 10 cents for the work on that task, and then went and redid the work. So so even back then in 2008, when we were working with fairly small data sets, we had to be very careful about data labeling and quality control on the data. So more recently, we've, so if you fast forward sort of 12 years, my group at ANU has built this IKEA assembly data set. So you can read all about this data set at the URL that I've given there, ikeaasm.github.io. And so this is a multimodal, multi-view video data set, right? So we've moved away from images and looking at video now, of the assembly tasks, of different assembly tasks. And what we want to do with this data set is be able to enrich our analysis and understanding of human activities by watching humans assemble furniture, IKEA furniture. So what we did was we collected 371 samples of furniture assemblies, as well as their ground truth annotations. We had 3 different calibrated RGB views, 1 depth stream. We annotated for atomic actions, so those are temporal segments with labels such as screwing in leg or flipping table, human pose estimation, object segments, and object tracking. And I'll just give you an example here of the data set. So here you can see the human skeleton. You can see the different segmented parts. So there are 4 legs there and a tabletop. And at the bottom of the frame, we're saying what action is being performed. So that center frame is spinning in the leg. And you can see here the variety of different different backgrounds, different poses that the human goes through, and the different parts that are being assembled. So how we've oh, okay, I'll just let that play through again so you can watch it a second time. So you can see here we've got home environments, we've got office environments, we've got lab environments, a whole lot of different views, as well as assembling on the floor and also assembling on tabletops or work surfaces. So what we've done with this data set is we've used it to build all of these algorithms for action recognition, for semantic segmentation, for object tracking, and so on. And we used that to put together a demonstration of a robot assisting a human in putting together a piece of IKEA furniture. So the robot is monitoring the human. It's determining what step they're up to in the assembly process. And it's then reaching for the next part that's needed, in this case, another leg, and it's handing that leg over to the human. So there are 2 deep learning algorithms that are running here. One is the perception system, which is watching the human perform the task, and the other is the manipulation system, which is controlling the robot and doing the grasping of the leg and then passing it over to the human. Okay, so the data collection effort here was fairly massive. As I mentioned, we've got 3 visual views of the scene. They were collected with 3 Connect cameras. We had a top view, a side view, and a front view. We had a large number of volunteers involved, so 48 human volunteers that assembled the furniture. And there was a little bit of imbalance there between female and male. I've got here 3 to 1, but it was actually the other way around. It was 1 female for every male of the volunteers. There were 5 diverse environments, 2 office environments, 1 lab environment, and 2 family homes. And assembly was done either on a work surface, so a tabletop, or on the floor. And then one of the challenging things about this data set was that the background was dynamic. It contained other moving people, distractors, and so on that weren't relevant to the assembly task. So if you look at a lot of activity recognition or action detection data sets, a lot of the times you can tell what action is being performed based on the context. Here, it's actually very, very difficult to tell what action is performed based on the context, because the context isn't relevant. It's the dynamics of how the person is interacting with the different parts in the scene, the different objects that are important. So in terms of just the data collection, we spent several weeks in just developing the infrastructure that allowed us to capture from the multiple cameras at the same time and calibrate the cameras and so on. There were then several more weeks of effort just in collecting the data. So we would assemble a piece of furniture, then disassemble it, bring in additional volunteers, find additional locations to do the data capture, and record and manage it all. And so, after maybe 2 or 3 months, we'd collected all of the data, but it was still not labeled. And we then had to go through the massive annotation effort in labeling the data. So by the time we got to the point where we were ready to annotate, we had over 35 hours of video. Each of the videos was between 1 and a couple of minutes long for a single assembly of a piece of furniture. And so that translates to over 3 million video frames. So clearly we weren't going to label every single video frame. We chose to subsample 1% of the frames for annotation. They were selected through both uniform sampling or skipping through the frames, as well as manually looking at keyframes that we wanted to annotate. So, you know, when a user is performing a particular task, we may want to get that particular frame labeled. So a person would go through and scrub through the video and mark which frames we wanted to get labeled. We had to be very, very careful about the task descriptions. So we had a number of different tools that we used for the different annotations that we wanted to collect. And there were a lot of decisions that needed to be made and communicated to the annotators. One really important one is how do you deal with occlusion? So if you're doing a semantic segmentation of a leg of a table, and that's occluded by a hand, do you label the hand as part of the leg, or do you label that leg as two different parts? The same with the human pose. Often a human is self-occluding, and you need to decide, do you get the annotator to give their best guess at where the joint locations are, or do you only annotate visible joint locations? And so this is where that last component that Dana was talking about, of how you can go back to an annotator and communicate visually what sort of things you want annotated, would have been very useful for us in particular. So we used a bunch of different tools for doing the annotation. We used one tool for doing the atomic actions, a different tool for human pose or skeleton annotation, one for bounding boxes and segments, and then another one for gluing the bounding boxes together into single tracks. Once we had all of these annotations, we then went through the process of visually inspecting them to ensure quality, and sending back poor quality annotations for rework. We also had the Mechanical Turk workers pre-screened to make sure that we were getting good crowdsourced workers in the first place to produce the annotations. Because we used a whole bunch of different tools for doing the annotation, we needed ad hoc scripts that would merge the different annotations together into a single annotation file, and also divvy up the work between Amazon Mechanical Turk workers, who we paid, student volunteers, and the research team for tidying up anything that was too difficult to communicate back to the workers or the students, or for efficiency, we could just sort of fix on the fly as we were doing the quality control. So as you can probably see from this, the organization, the back-end management, the quality assurance, and the tools that we use were all far from ideal. And I don't think this is abnormal for a data annotation effort. Often data annotation is not put forefront in the project when you're thinking of a machine learning project, and it's sort of very, very ad hoc. But based on this experience, we started looking around at different tools. We ended up developing one of our own tools, but I've since discovered dLabel, and Dana and I are sort of talking about how to collaborate on that tool. But this is the tool that we developed, and we had a number of design criteria that we wanted for the tool. So the first was that it should just be simple and efficient for a non-expert to use. We didn't want to have spend a lot of time training up an expert. Now, depending on your annotation task, maybe it is worthwhile training an expert annotator. But for us, we just wanted to hand out the videos to students or Mechanical Turk workers and have them very, very quickly be able to annotate. We wanted to support a number of different annotation types. I don't think this is particularly controversial. Most annotation tools these days will support bounding boxes, regions, tracklets, and so on. We needed it to run in a browser without any external libraries, and we also don't do any server-side processing. So this is a standalone tool that will run in your browser. You can disconnect from the web. There's nothing you have to install locally, and you can just go about labeling. But it does have the option to integrate with a back end if you choose to. And then, of course, compatibility with most browsers and operating systems, including tablets. So we found that a lot of our students and us, we would spend time annotating, but sometimes you'd do that in front of the TV or sitting in a cafe with a tablet. And so we wanted to have the option where you can annotate in tablet mode, and that introduces some other design decisions in terms of how you present the annotations to the user, how they click and modify annotations. And then finally, it's open source. Now, one of the difficulties that we had in the original annotation was tracking the object parts. So if you remember the video of the person putting together the IKEA furniture, a lot of the parts are the same. So we have these identical parts such as table legs, and we wanted to be able to annotate tracking those table legs across the video. Now, often if you just flick through a video one frame at a time, the annotators would get confused as to which leg they labeled as leg 1 and which they labeled as leg 2, and it was very laborious for them to sort of scrub backwards and forwards from previous frames to the next frames in order to get that consistent labeling of the different table legs. And so what we did in this tool is we allowed the user to see 2 different frames at the same time, a previous frame and a next frame, and they could sort of skip through. And we found that this allows annotators to get much better consistent tracklets where they don't confuse these nearly identical parts with each other. So I should point out that the tool is only for videos. It doesn't handle images or image sequences. There's no data or project management built into the tool. There's no version control or auto saving. It's a single worker model. There's no automation of annotation, and there's no facility for review or annotator assessment. So it's a very basic tool designed for what I would call sort of small labeling jobs, not something that you would necessarily use at scale, or would certainly need the back end management framework if you were going to do this at scale and over a long period of time. All right, so the sort of take-home messages from my presentation is just to sort of sum up, is that data is the fuel of machine learning. I think everybody sort of knows that, and the cleaner the data, the more efficient the engine will run, so the better results that you'll get. Annotators in particular need very, very clear instructions with examples of what's an acceptable and what's an unacceptable annotation, and they need to be reminded of these regularly. So they need to be trained, and then they need to be assessed and given feedback. Many of the tasks are subjective, and so you need mechanisms for measuring the disagreement between annotators, which will allow you to build algorithms that can take that into account, or drive the annotations towards some sort of consensus. So get agreement between the annotators on what should be labeled and what shouldn't be labeled. The data collection process is not a one-off effort. It's not something that you sort of fire and forget and do once and then get on with building your application and doing your machine learning. It's very much an ongoing process that involves quality control and refinement. And even after you've built your application, you then may need to go back and get more data labeled. So for example, once we collected data, got it annotated, trained our model up, when we got the robot to assist the human in assembling the piece of IKEA furniture, we found that there was a huge imbalance in some of the actions that the algorithm could recognize, such as spinning in a leg, versus other actions such as flipping the tabletop. And that's because there are 4 legs per table, so you would see 4 times as many instances of assembling or screwing in a leg versus flipping the table. And so we went and then collected more data to balance out the data set for that particular application. And probably the last and most important take-home message is that tooling is essential to support and possibly automate the annotation pipeline and the back-end data management. You can run into a lot of problems if you're not tracking what's been annotated, whether you've reviewed those annotations and sent them back to rework, and so on. And so having tooling that supports all of that is absolutely essential. Okay, so I'll leave my presentation there, but I'm more than happy to take questions and answer any questions.
Fireboard?
Yes. Do you have my voice? Can I ask a question?
Yep, go ahead. I can hear you.
First of all, thank you all for the great presentation. And one thing you mentioned in your presentation was about running your annotation tool on handheld devices like the iPad or something like that. I was going to ask if you port all of the capabilities of desktop app to that iPad app, or is that have some kind of limitations? Can you more elaborate on that? Yeah.
Yeah. So all of the capability is there. What we did was change how the user interacts in some cases. So clearly on a tablet device, you don't have hotkeys that you can press. So if you're doing things like annotating a region where you're clicking around points, when you're doing that on a desktop or a laptop, we had hotkeys which allowed you to modify whether you want to delete a point or insert a point, or just sort of move the location of the point. With the tablet, you actually have to go down onto a drop-down menu and you have to select a different editing mode. But apart from that, it's the same functionality. What we don't have in the tool is the ability to zoom into a region. So if you're on a small tablet, the resolution of the frame that you get to see is limited by your screen real estate. Whereas if you're on a desktop, then you can zoom in with your browser. So those are sort of the only two things. But apart from that, you get the full capability of the desktop version. And again, it's because everything just runs in the browser. So there's no need to install any separate libraries sort of locally. As long as you've got a browser on your tablet or your desktop, you can use the tool.
Is there any more question? Ali?
Thanks for the presentations. Steve, I have a question for you. You mentioned using 4 tools, and my question is, were there any auto annotation or tools that would help during the creation of the IKEA assembly dataset?
Sorry, with annotation tools or other?
Yeah, you mentioned using 4 tools.
Yeah.
I wanted to ask if there were any auto annotation involved in any of those tools.
Oh, so there wasn't automatic annotation in those tools. For that data set, the ground truth was only data that a human had annotated. In order to train the algorithms, we produced what we called pseudo ground truth. So what we did with the training data, we had 1% of the frames labeled. For each separate video, we would train like a semantic segmentation algorithm just for that video, just on the data that was annotated for that video. And we would then run that semantic segmentation algorithm over the entire video and get what we called pseudo labels. And then those pseudo labels were used to train an algorithm across all of the videos in the training data set. And then we would go and we would test on the test data set. So I sort of think of that as more to do with the training phase, because that data wasn't really verified by a human. It was like this semi-supervised task to help give the training algorithm more data. And then testing, when we report results, that was all done on the 1% of annotated frames on the test data set, where a human had verified all of those annotations. There was no automated process there in producing those annotations.
Okay, great. Is there anything you would like to see in the tools? I mean, what types of automation?
Yeah, so I think I mean a lot of those features that that Dana sort of demonstrated would be really useful. The ability to flag things and send them back for correction. The ability to, I guess, monitor an annotator as they're doing the task, particularly when you're training a new annotator, and then be able to sort of teach them and correct them for what you want. And then sort of leave them to do it on their own. I think that would be great. And then maybe some more sophisticated tracking between instances. So I think you could, you certainly wouldn't be able to do this with an online tool where you're just doing simple interpolation between two labeled examples. But if you had some back-end object detector and tracker, you could do much more sophisticated tracking across longer videos. I think that would be useful as well.
Thank you, Sanas, as well. Thanks, everyone.
I would like to thank everyone on behalf of dLabel.org team, and based off the feedback we're getting today from this presentation, we will create a follow-up events that is more targeted towards a specific interest. Please reach out Dana and his team for any particular suggestion. Thanks very much, Steve, for your time today.
Thank you, and thank you, everyone.